Okay, so I wanted to quickly do updates then on our other two favorite spacecraft, which is the two rovers on Mars. And we've had a couple of milestones since I last talked to you. First of all, we've passed the 5,000 day mark for Opportunity. And and for those of you that are new, I say a sol rather than a day, and that's because on Mars a day is 24 hours and 37 minutes long. So we talk about solar days, or sols, and so this is 5,039 Martian days. The spacecraft landed in late January of 2004. It was expected to last 90 days, or 90 sols, and so we're still going strong. And so just the lay of the land here, this was where they landed. They've been driving for, what are we at now? 14 years. And for the last several years, they've been skirting the rim of this huge crater, Endeavour, which is about 20 kilometers in diameter. And they've been recently in this valley that goes down into the crater. And so this is, if your eyes are good enough, you'll see this little yellow line, and where they've been paying attention is this, which is called Perseverance Valley. And this, from orbit, it looks like there was water that flowed down the rim of the crater into the valley. They detect clay minerals in this area, and so clays are formed where you have liquid water interacting with rocks. And since that's one of the primary goals of this mission, is to find out if and when there was liquid water in these areas. That's sort of what they're up to right now. And so here's what they've been doing for the last year or so. And so right now they're sitting on a slope on the edge of the valley, and it's winter time there, so they've got the solar panels tilted toward the sun so that they get extra electricity. And they have had some solar panel cleaning events where the dust has been blown off of the solar panels, so they're in good shape power-wise, and it'll be another several months before they actually start routinely moving again. And this is just a sort of a 3D view of this valley, and they're pointed this way, so north would be off in the direction to the right here. So they've just passed last month the 5,000 day mark on Opportunity, and this was the day before that. This was sunrise from where they were sitting. So that was just a commemorative image. And this was an image taken this morning that I was able to pull down just before I came in here. And so this shows some of the tire tracks, sort of a selfie in a way. There's the shadow of the rover. And I've told this story many times, but it sort of bears repeating for those of you that haven't heard it. When they first landed, they were testing this auto drive system, sort of like what Uber is doing, except there's no Martians to run over. And the way this works is they've got cameras down near the wheels, and they're stereo cameras, and they're fisheye lenses, so they look out either ahead or behind the rover. They can make a 3D map of where they're going, and if they see an obstacle, they'll try to steer around it. If they detect a steep slope, they'll back up and try to figure out a way around it. So when they first tried using this software, they got into a situation on the second day of using it where the sun was behind the rover and it cast a shadow like this. And the rover said, "Oh my God, that's a pit I'm going to drive into." And it stopped and it backed up and kept backing up because the shadow was following it. And it finally just stopped and called home for help. And so it, quite literally, it was afraid of its own shadow. and they were able to, there's sort of a dial in the software for courage, and they dialed that up a little bit so it would at least try to put its toe into something like this, and then if it was good, it would keep sort of moving slowly into the shadow. So that, you learn, and they did, but that was sort of an entertaining phase of the mission way back when. Okay, and this is another image that was just returned. So this is a very dusty looking image, but this is the nearby crater rim. This is the interior of the crater that they're trying to drive down into. And so here's the recap. Today is day 5039. They've driven a little over 45 kilometers and returned 226,000 images so far. And just again to put this in context, the mission design was for 90 sols, 1 kilometer of driving, and 1,000 images. So the people that backed the warranty on this made out like bandits. Okay, so the other rover that's active right now is Curiosity, and it also passed a milestone, which is its 2,000th day on Mars. That was 6 days ago. And so, again, where they landed for Curiosity is inside this much larger crater than Opportunity has seen. It's called Gale Crater. It's about 150, 160 kilometers in diameter. This is the targeted landing site. And there's this large mountain in the middle of the crater called Mount Sharp, which is stacked sedimentary rocks. It's about 18,000 feet thick. And so this is the view from the surface of Mount Sharp when they landed, a little closer view. And so what they've been doing in these 2,000 days is getting closer and closer to the foothills of Mount Sharp. They've been drilling into rocks, sampling them, and trying to determine what the environment was like when these different layers were laid down, and to determine if the environment could have supported life way back when. And so I think the next, the one concern that's happened in about 6 months ago is the drill. The rock drill started having problems where they were having trouble placing it. When they'd start drilling, it would just sort of move around instead of being stationary and drilling a hole. And they spent a long time analyzing that. And I think there's a video coming up, but I'm getting ahead of myself. So this is the map from overhead of where they are. So Mount Sharp is down on the stage here, and they landed up here. They've driven sort of paralleling these thick sand dunes. They didn't want to get stuck in the sand, so they drove down to where there's a break in the dunes. And right now they're sitting right where that green X is. And so this was the 2,000-day anniversary photo that was released on the anniversary. And so they're getting close now to where they're going to start getting into really interesting terrain as they near Mount Sharp. And so here's the story about...
Since Curiosity landed on Mars in 2012, it's used its drill to acquire samples from Martian rocks 15 times. But a little over a year ago, in December of 2016, Curiosity's drill started giving it problems. The drill's feed mechanism, which is responsible for moving Curiosity's drill bit into and out of rocks, didn't move when commanded. When Curiosity drills into a rock the way it was designed to, the drill's 2 stabilizer posts touch the rock first to steady the arm while the drill's feed mechanism moves the bit forward into the rock. Without the feed mechanism working, we can't drill that way. To solve this problem, we do what we always do. We worked it out in the test bed using Curiosity's twin on Earth. Our team of engineers and scientists have been working for months to figure out a way to collect and deliver rock samples without using the feed mechanism. Here's what we came up with. Using our new technique called feed extended drilling, the stabilizers are not used. The bit is now in a forward position extended past the stabilizers. Moving the drill straight into a rock and retracting safely without the stabilizers is challenging. We move the arm instead of the feed mechanism to place the bit onto the rock and press it forward as it drills. After making contact, we apply a light preload and drill a shallow pilot hole. We use a force sensor in the robotic arm to give Curiosity a sense of touch. This lets Curiosity adjust its arm motion and avoid getting stuck while drilling, kind of like you might adjust your arm while drilling into a wall at home. After drilling, we use a similar technique to retract from the hole without getting stuck. We recently tried this method using Curiosity on Mars, and here's how it turned out. This picture shows the first hole drilled on Mars ever with this new drilling technique. Even though we can't see the hole in this image, we know we drilled about 1 centimeter deep. The hole itself is buried under the powder generated during drilling. This is a good sign for the new drilling method. Next, we have to drill a deeper hole to collect sample and demonstrate our new techniques for delivering the sample to Curiosity's 2 onboard labs. That will come in the days ahead.
Okay, so that's good progress. They're finally able to collect samples again. And this is an image taken a couple days ago of where they're sitting right now. And you notice this sort of trough here with little pebbles along the outside of it. And it turns out with the analysis they've been able to do with many of their onboard instruments, the spectrometers in particular, this sort of very fine debris is made out of hematite. And that's something that Opportunity saw at its landing site, and it's a good indication that this area was in contact with sort of acidic water at some point in the past. And hematite is an iron sulfate mineral, and there's lots of iron in the rocks. There's lots of, sulfur is an easy thing to dissolve in water if you have groundwater coming through. And so the interaction between the rocks and the water then combines the sulfur and the iron to give us hematite. So they're spending a fair amount of time now. This is the strongest hematite signature they've seen at the Curiosity site. So they're going to be sampling this and giving it the full treatment with all of the onboard instruments. So the recap here is day 2006. It's driven 18.5 kilometers and returned. I expect next month when we come back, we'll be at the 500,000 images mark. So both of these continue to return really good science and are both relatively healthy, and we expect them to last for quite a while longer.